Hello everyone, Eddie the Magic Monk here, doing a few lessons on exponential equations. This is a topic that is studied quite often towards the end of high school, and it could potentially confuse a lot of people if you don't get the simplest explanation. So I'm going to explain it in the simplest way possible, so it is impossible for you to not get it if you know a little bit of maths. So what we're going to do is we're going to use a real life situation to slowly lead you into developing an exponential equation. So the situation is, we are sitting in a science lab and we're growing some bacteria, which I'm guessing you would have already done some sort of experiment like this in a science lab in high school. So the bacteria is doubling every 20 minutes, and initially we already have 500,000 bacteria sitting in the test tube. It doubles every 20 minutes. How long will it take for the number of bacteria to reach a certain amount? So let's write this out slowly. So initially, at time is equal to 0, at time is equal to 0 minutes, we have the number of bacteria, let's just call it B. The number of bacteria is equal to 500,000. Okay, and at time is equal to 20 minutes. So 20 minutes has gone past. How many bacteria do we have? We have 1 million bacteria, because we have doubled the amount of bacteria. And then at time is equal to 40 minutes. We then double it again, so now we have 2 million bacteria. So the question is, how many times do we have to keep doubling the bacteria? Okay, how many times do we have to keep doubling until we get to 500 million? Okay, how many times do we have to keep doubling? Oops. How many times? And once we figure out how many times, we can easily figure out how many minutes. Right, because we know that it doubles every 20 minutes. So let's say if we know that if we know that we have to multiply it by 2 for 10 times, then we know that it's going to be 10 times 20, which is 200 minutes. Okay, so we want to slowly start to develop an equation. So the equation will look something like this. We got 500,000 bacteria initially, and we keep multiplying it by 2 however many times until we have 500 million bacteria. Okay, but we don't know how many times we have to multiply it by. So then what we're going to do is we're going to rewrite that as 500,000 times 2 to the power of n equals 500 million. So we have used a equation now to represent our situation, an exponential equation, where the unknown variable is in the index. So 500,000 times 2 to the power of however many times will give us 500 million. And now we just have to solve for n. Right? Because once we find n, we can find t as we've expressed previously. So let's now use logs. So I'm assuming you guys have done logs, but let's try and solve this. So 2n equals, I'm going to move the 500,000 to the other side. So it's 500 million divided by 500,000. So I'm going to use the quick way of division by crossing out the same number of zeros from the top and the bottom. Okay, hopefully you would understand why I'm doing that, because I'm dividing by 100,000 from both the top and the bottom of the fraction. So the answer is 5,000 over 5, which is 1,000. Okay, so 2 to the power of n is 1,000. Now, in order to solve that, I can log both sides. So log bracket 2 to the power of n equals log 1,000. And now I can use one of the log rules to move the n to the front of the log. So it's n log 2 equals log 1,000. And then I can move the log 2 to the other side. So it is log 1,000 over log 2. And you can simply type that into the calculator. And I have the answer 9.96. 9.96 is the number of 20-minute periods. N is the number of times you're multiplying it by 2, which is the number of 20-minute intervals. So in order to get t, we would have to multiply n by 20. So it's 9.96 times by 20, and we will get 199.31 minutes. Okay, that was actually 9.965 something, so I'm gonna just leave that 5 there. And the answer is 199.31 minutes. Now, as we advance further, we're going to talk about whether we can count portions of the 20 minutes. Because according to the definition of exponential equations, right now we can't actually account for less than 20-minute blocks. So we actually have to say 200 minutes in this case, because the question does not really define, okay, is the bacteria increasing gradually, or is it increasing at the end of the 20 minutes? Is it doubling at the end of the 20 minutes? It doesn't say that very specifically. So really we can only say 200 minutes in our answer. And we're going to investigate exponential equations further later on to discuss whether how can we find out exactly how many minutes it will take to get to a certain amount at the end. Okay, thanks for watching, guys. See you next time.